Well, I'm kind of glad we've moved out of limits, and now we're going to kind of apply the that limit concept, and we're going to move on to what's called the derivative. And we're going to first start with the definition of the derivative, which a lot of you aren't going to like, but we got to at least build the derivative, and we're going to do that by using the limit. And I got a nice picture here to look at. Okay, so this green line here is the graph of our function, and we got a bunch of straight lines here, and I'll explain that obviously. Well, we got two important points here on the graph, and that's x and f of x. So, and I've kind of centered that at the origin, but more generally it's x, f of x. And then we've got this other special point up here, and it's x plus delta x, f of x plus delta x. And what I mean by this delta x thing here is that if my x is here and delta x is some number, we're going to add 2x. So x plus some number, and that and that number is delta x. And delta really means difference in x, but just think of it as we're here at x, and then we're going to add some number to it, so it looks like maybe I don't know what that is, 4.5 or something, if that's 4. So if x were 0, I should say, and we're adding delta x would be like 4.5. So this whole thing right here, since this would be 0 plus 4.5, the whole thing would just be 4.5. Okay. So we're coming out some delta x, and I go straight up, right? So that's my y value, f of x plus delta x, and this is my new x value here, x plus delta x. All right. I'm going to draw a line that passes through and this looks like the origin here, so we'll just say it's the origin. But I'm drawing a line that passes through the origin, and then this point right here, x plus delta x, comma, f of x plus delta x, alright? Okay, and you notice the slope of the line, alright? Take a note of the slope of the line. Now, if I take this point and I move it down, and now here's our new line. And by the way, this line is known as the secant line. The secant line is passing through 2 points on our graph here, and we call this line the secant line. But if I take this point and I move it down, as I move it down, okay, so here's a snapshot in time, and if you've noticed that our slope is decreasing, right? So let's say the slope here is, I don't know, it's a little more than 1, and we'll say the slope of this line here is a little less than 1. And then you keep moving it down. Now as I move this point down, what's actually happening to delta x? Well, delta x is what? Delta x is decreasing, right? Delta x is decreasing. And you notice that the slope in our line is also decreasing. So we keep moving it along, and our secant line, as you can see here, the slope of the secant line is also decreasing. Okay. Now what happens when delta x starts getting closer and closer to 0, right? Delta x is getting smaller and smaller and smaller. Well, what's happening here is the secant line, as you can see, the slope of the secant line is, well, in this particular case, it's what? As delta x gets closer and closer to 0, the secant line, right, gets closer and closer to, the slope of the secant line gets closer and closer to 0. Alright, so we say as delta x approaches 0, our secant line is approaching what is known as our tangent line. And this red line right here is considered to be our tangent line. Now what I'm going to do here is I'm going to find the slope of the secant line. I want to find the slope of the secant line. So it's just like finding the slope, right, of line that passes through 2 points on the graph. It's y2 minus y1 over x2 minus x1, and that's what we're going to do. So this right here is like our y2 minus our y1, and this is, if this were x2 minus x of 1, what would end up happening is it would all cancel out, and you would just get delta x in the bottom. I should have probably written this out.